Okay, this is the P3 paper from January 2024. It's question number 2. This is a numerical methods question. We're going to be locating roots in this first part. We're going to be doing fixed point iteration later on with the question. So let's read it and see what it says. Curve has the equation y equals fx, where fx is given by that function, and we've got to show that there's a root alpha in the interval 2 to 3. Okay, so if we're going to do that, all we're going to do, we're going to find f2, we're going to find f3, and what we'll show is that, for example, with this one, this is a negative value, this is a positive value, or then somewhere in between those two is a root. It could go positive, then negative, or negative, then positive, as long as there's a sign change. But when we get to the final answer, really important that you use the correct language, and I'll talk about it when we get there, but let's at least get started with it. So our function was given by fx equals x to the 4, 5x squared, plus 4x minus 7, and I'm going to find f2 and f3 and hope that there's a sign change. So f2, 2 to the 4, 5 lots of 2 squared, 4 lots of 2 minus 7, and that works out to be equal to minus 3, and then f3, 3 to the 4, 5 lots of 3 squared, 4 lots of 3 minus 7, and that works out to be equal to 41. So there is a sign change. The language I'm going to put now in my answer here, I insist my students pretty much copy word for word. So let's write it down so you can see what it is. Since there is a sign change, and it's this next part, and fx is continuous in the interval. Sorry, just get that all written down. Then there's a root. Therefore, fx is equal to 0, has a root alpha. Now, the reason that we have to have that second part about the continuous in the interval is that there could have been another possibility where we had a situation where a graph did something like that and something like that. There's a sign change, and yet there's no root because the graph's not continuous. So that's explaining why, but that particular phrase there, you go back through any of my videos, you'll see almost an identical one each time. Don't mess about and have the possibility of losing a mark on that one. Part B, what does it say? Part B, right, we're getting into the iterative stuff now. So it says, first of all, show that this can be rewritten as this. Well, there are lots of options of where I can get my x equals. It could be x equals coming from the 4x, coming from the 5x squared, or coming from the x to the 4. But there's a massive clue, look, in the fact that here we've got the same part of the term there. So it looks to me like I'm starting off with trying to isolate x to the 4. Let's go through it and I'll explain that in a little bit more detail then. So what I'm trying to do is to rearrange the equation x to the 4 minus 5x squared plus 4x minus 7 equals 0 into the virtual iterative one that we're going to use straight afterwards. So I'm starting off by saying I'm going to isolate my x to the 4. So everything else goes over to the other side. Yeah, so we've done that. And now how do I get x equals? Well, you could square root and square root again. You could divide everything by x cubed, but go back and look and see what we've got here, and I can see that I've got a cube root in there and I've got a divided by x in there. So those two things are why I'm going to do my next step. What I'm actually going to do, because it's really strange otherwise, to say x cubed is going to be equal to 5x squared minus 4x plus 7 all over x. And the reason I did that was because I was having a sneaky look at the answer, because the next step after that then is to say x is cube root of. So this is one of those questions where having a quick look at the answer will certainly help you with the method for getting to that part there. Let's just tidy that up a little bit, move that over a bit. Okay, yeah, so we've managed to show then that x can be written in the format as asked for there. Then for the next part, it says let's use the iterative formula. What are they asking us to do? They're saying iterative formula is there. Starting with x1 equals 2 and using the iterative formula, find to 4 decimal places the value of x2. Okay, well, we can do that. So part C, I've got x to the n plus 1. So let's just write out what the formula is. X to the n plus 1 is equal to the cube root of 5x to the n squared minus 4x to the n plus 7 all over x to the n, and they're saying start with x1 equals 2 and then work out what x2 is. Well, x2 then will be just putting x1 in, won't it? So it's the cube root of 5 lots of 2 squared minus 4 lots of 2 plus 7 all divided by 2. You can do that on the calculator then, and it comes out to be 2.11792, but they want it to 4 decimal places, to 2.1179 is our answer for the first part. Then it says, find to 4 decimal places the actual value of alpha. We want the answer for the root correct to 4 decimal places. So what we're going to do is we're going to say, okay, if that's x2, x3 then is just putting 2.11792, the whole number, back into the equation. If we do that, we get on our calculator, I'll get on my calculator, 2.1468460021. I'm going to put that value in, and then I'll get out on my calculator x equals 2.154063147. If we put it in, we're going to keep getting. So what I've done is I've actually done those values, and then we'll explain why I did the ones that I did. Let's just put all those ones in. So what I did was I just kept repeating it and putting it in. I know you guys will be able to do that really quickly using your functions on your calculator to get the iterative process to come out really speedily when we're doing this. And I did it so that I got all of those answers. Now, I want to focus on why did I go so far. I wanted my answer to 4 decimal places. So if I want my answer to 4 decimal places, it's that, then that, then that, then that. Now, as I'm going through here, I can't stop until I get to the stage where it stops changing over those 4 decimal places. So now when I get to x7, x8, and x9, it's 2.1564347. Then it's 2.15646. So I'm talking about is here. At that stage, that hasn't quite settled down enough yet. But by the time I get to that third one, then we can say, right, now that's got to that 7 there. It's not going to change anymore. You can go x10, x11, x12 if you want. But now I've got enough of a confidence level to be able to say, right, my value there then is 2.15. And actually the 7, the 6, they're both going to do the same thing. They're both going to mean that it's going to be 6.5 that it's closest to rather than 6.4. So make sure you do enough of those versions of the iterative formula so that you are confident enough to get it to 4 decimal places for that last one. Okay, hope that all makes sense to you.